Concept of energy on SHM. Right. So have a look. Yes, beta. So concept of energy on SHM. Right. So I can say student in previous class, in previous theory lecture of like say my dear in SHM, as I say, I discussed X as a function of T, V as a function of T, A as a function of T with graph, detailed solution with illustration as well. Today evening student also I solve few J advanced PYQs based on oscillation only. Right. So now students, I can say I'm going to discuss the here that is student concept of energy, concept of energy on SHM. Literally, my dear, it's a very good topic here. Yes. So now, student, I'm going to start the class. So, student, here I can say little here. Just I'll manage everything. Okay. Just little bit. Okay. Fine. Okay. So now, student, I'm going to start the class here. So this is what, my dear? Okay. So concept on SHM. Concept of energy on SHM, right, my dear? Okay. So have a look. Student Jasrisha. Yes, beta. Concept, concept of energy, concept of energy on SHM. Concept of energy, my dear, on SHM. Right. Okay. So listen carefully, my dear. So here, student, first I'll discuss. Student, first I'll discuss potential energy in SHM. What, my dear? Potential energy in SHM. Okay. I hope all of you know basic point of SHM, my dear. So this is left extreme, left extreme. This is my dear. This is my dear right extreme. This is my dear right extreme. Did I God bless you for your reply? Now, students, it's a mean position. I hope all of you know, my dear. This is mean position, right? Okay. So, students, here I'm taking few basic consideration. Let us say your motion or any particle got displaced, that is distance x from mean position. So let us say, my dear, you have to move x and you are discussing at a what distance dx. You have to move x, your motion with respect to mean position, my dear, and this is what you can say dx. We are interested to find potential energy. We are interested to find what, my dear? Potential energy. So you can say mean position is the initial position of particle, my dear. So you can write over here, this is potential energy at mean position minus u as a function of x. U as a function of x, which is equals to what, my dear? You can say work done by conservative force. Work done by what? You can say conservative force. Okay, so use the here students can write u at mean position minus u as a function of x. I hope all of you remember here. Work done you can write force into displacement and distance. And what's the force over here? In SHM, always we have to take equation of SHM, or you can say oscillatory equation of SHM, which is equals to F is equals to minus kx, my dear. So here I'm going to write, or I'm writing kx into what's the work done? Force into displacement and distance. Force into displacement and distance, bacha. Okay, now here this is, you can apply the limit, students. You can say, let us suppose if you are at mean position. So what's the lower limit, my dear? 0 up to distance x. What you can say? This is x. This is what, my dear? You can say x here. Okay. So with this do bit of basic integration. I'm expecting here from all of you. Into beta u as a function of x minus half kx square minus what, my dear? Half kx square. So this is what you can say potential energy as a function of x. Okay. Just beta subtract just this mean position in right side. You can write u as a function of x, which is equals to minus kx square minus u at mean position. This minus you can say beta happy birthday. So finally you can write, my dear, u as a function of x, which is equals to half of kx square plus u at mean position. MP implies it's a mean position, not a Madhya Pradesh. So keep in your mind. But students generally are 99.99 cases, students generally 99.99 cases, what we are considering, we assume that is what, my dear, u at mean position, which is equals to 0. 99.99 cases will take this consideration. So we can write, students, u as a function of x. You can write u as a function of x, which is equals to half kx square. U as a function of x, you can say half of kx square. U as a function of x. What you can write, my dear? Half of kx square. Okay, fine with that. Next year, I'm going to derive next equation because this is x as a u as a function of x. We can also write u as a function of t. How, students? So just, my dear, you can take snapshot, everyone. Okay. Now, student, I'm going to just discuss next function. You can say this is what, my dear? Potential energy as a function of time t. What, my dear? Potential energy as a function of time t only. Okay. So I hope all of you remember here. Equation of SHM x as a function of time t. X is equals to a sine omega t. So just now, student, we derived result u as a function of x. Just now, student, we derived result here u as a function of x, which is equals to half kx square. So x now, beta, just replace a sine omega t. So u as a function of x, you can write half k a square sine square omega t. So this is, my dear, you can write u as a function of t. It's not a function of x. U as a function of t. Potential energy as a function of time. You can say half of k. What, my dear? Half of k a square sine square omega t. What which are u as a function of t? Half of k a square sine square omega t. Right. Here, I can say, student, I'm not considering it. What is the initial phase? If there is phase mentioned, so simply here you can say sine square omega t plus phi. What, my dear? You can say sine square omega t plus phi. So these things are literally you have to keep in your mind. Highly important and highly, I can say with useful here. Now, students, I'm going to derive that is what I can say kinetic energy. Students, now I'm going to derive this is kinetic energy as a function of x. So first student, I'll write kinetic energy formula. This is half mv square. I hope student all of you remember v as a function of x. As I derived, I can say if you don't know, these all, if you want to enhance your knowledge, you know how it came, so you can go and just watch, I can say lecture one of oscillation. So this is V students, you can write omega root over this is a square minus x square. Omega beta, what you can see a square minus x square, right, my dear? Okay, this thing with that we can put over there. Yeah. So we'll get finally kinetic energy as a function of x. Half m, this is omega square a square minus beta is half m omega square x square. Here, beta, I'm just again here going to tell one thing. Beta, the omega square you can write k upon m. Omega square, my dear, you can write k upon m. Right. So, beta, this thing you can just rewrite with the above expression. Kinetic energy as a function of x. So, this is 1 by 2 m into beta. This is omega squared. You can say k upon m. Beta g, this is a square minus half m beta. Omega squared, you can write students k upon m into x squared. Now you can see this mass finish, this mass finish. So kinetic energy as a function of x. As a result, now onwards you can remember this is what, my dear? Half of Ka square minus half of Kx square. So now onwards, keep in your mind for a kinetic energy as a function of x. My dear, kinetic energy as a function of x. Now, students, I'm going to derive next expression. That is what, my dear? Kinetic energy as a function of time. Take snapshot, my dear. Take snapshot, my dear. Take snapshot, my dear. Okay, so now students, I'm going to derive that is kinetic energy, student kinetic energy as a function of kinetic energy student as a function of time, right? So this is next student derivation, kinetic energy as a function of time. So it's nothing, students. First, you need to write half mv square, half mv square. I hope all of you remember. Otherwise, if anyone want to explore your knowledge, how it came, with like v as a function of x, v as a function of t, for that condition which is right here, v is equals to omega. This is what, my dear? Oh, already I use here v as a function of x. So now, students, I'm going to write here v as a function of t. So it's nothing but v is equals to a omega cos of omega t. Student, here I'm not considering any initial phase of any particle, right? That's why I use only v is equals to a omega cos omega t. V is equals to a omega cos omega t, my dear. So you can finally say kinetic energy as a function of time t, which is equals to half m, and v, what you can say, this is a square omega square, this is cos square omega t, cos square omega t, right? It further again you can simplify here. Omega again you can use, students, omega square which is equals to k upon m. Omega square which is equals to k upon m. So this is kinetic energy, student, as a function of time t. You can write half m What, my dear? This is a square and omega square. You can write k upon m into bacha cos square omega t. You can see at this m happy birthday. So kinetic energy as a function of time t, which is equals to a half ka square cos square beta g omega t. So this is, students, we go. I'll write here, rewrite again. Kinetic energy as a function of time t, half of Ka square cos square omega t. Now, student, I'm going to write here expression of total energy as a function of x. What, my dear? Expression of total energy as a function of x. Okay, so this is beta total energy, or you can say mechanical energy. So total energy as a function of x, my dear, you can write half m v square. Means you can say you must write. I'll write in next step. Kinetic energy as a function of x only, minus beta g half of, you can say, kx square, half of kx square. So just now, beta, we derived here. Just now, student, I derived that is, student, kinetic energy here as a function of x. So what is this, my dear? Yes, this is, because this is a kinetic energy as a function of x, half of ka square minus half of k x square. Half of k a square, because this is minus here. So it's a summation of what is the total mechanical energy? Total mechanical energy is what, my dear? Summation of kinetic energy plus potential energy. Again, I'm repeating, my dear student, total energy is a summation of what, beta, you can say, kinetic energy plus potential energy, right, my dear? So this is the kinetic energy here. You can say half of Ka square, बच्चा जी, minus beta half of kx square plus half of kx square. Now you can say again, this is cancel each other. So finally you can write which as a total energy as a function of x, which is constant always, half of ka square, half of k square. So you can say mechanical energy of system in SHM always what, you can say, my dear? You can say, my dear, this is what remains constant. You can say, bacha, this is what remains constant, right? So kinetic energy, bacha ji, you can write always remains constant in what? SHM. Kinetic energy not. Total mechanical energy, beta. Total mechanical energy in SHM always remains constant, which is equals to half of K A square, where K is what? Spring constant and A is what? Amplitude. K beta is spring constant and A is what, my dear? Amplitude. Okay, now what's about it? Have a look at next. More interesting, students. I'll write here all formula together. So this is u as a function of x. U as a function of x. Half of kx square. Student, multiple time, not a single time. Not a single time, multiple time. J asked only this formula. Oh, someone replied, revert. Okay, got it. Reply. Okay, very good. Very good, bacha. No, yeah, literally, I'm feeling proud here to see all of you. Those who I can see in the night around time going to finish 12 o'clock, still you are watching Physics Point live stream. I'm proud of you, bacha. All the very best here. Literally, beta, all the very best here. And I can say those students, I can say till now, watching, showing, replying, showing reaction, yeah, beta, all the best. God bless you, beta. So EU as a function of x, beta. Now, students, I'm going to write kinetic energy as a function of x. What are students? Half of k a square minus dear half of kx square in third year. Third beta, what I can say? Mhm. Yes, total energy as a function of x. This is what? Half of beta k square. Half of k square. Now, student, I'm going to draw a graph here. You can say U versus X, total energy H versus X, and kinetic energy is a function of X only here. So beta 1 point remains constant here. So keep in your mind. Uh, this is what, my dear? You can say amplitude. Yes, beta. This is amplitude here. Left extreme position, my dear. Right. Next one. This is what? Plus amplitude A bacha. Okay. Uh, this point is nothing here. It's the mean position. This vertical line is what representing, my dear? This is the mean position, right? Okay, fine. So with that, you can just compare this one. Y is equals to x square. So y is equals to x square. Which one has a less degree? Y has a less degree, right? So graph mouth open towards y. This is the point at which you can keep in mind. If you want to plot a graph like y is equals to x square equals to y, you have to compare which one has a, you can say, my dear, that is a less degree, right? Mouth open towards this. So, beta, this is what you can see every energy, kinetic energy here, potential energy here, total energy here only, all are on vertical axis. So, you can see this is what mouth open for this graph towards the potential energy, bacha. So, first thing at potential, this is, my dear, you can see graph for total energy. This is what is graph for total energy because this is what remains constant. This is what, my dear, remains constant here. Now, student, I'm going to draw that is u as a function of x. So, mouth open towards what, my dear? You can say mouth open here towards y-axis, right? So, this is what, my dear? You can say u as a function of x. This is what, my dear? You can say u as a function of x. So, beta, I can say we have a last one here. Yes, beta, we have a last one. So, this is what, my dear? Because it's with a half k square minus half kx square plus half ka square minus half of kx square. So graph beta just make beta graph it's positive. Yes, beta. You can just make graph here. This is yes, beta. So this is what you can say graph of, you can say bacha, kinetic energy is function of x. So this graph, my dear, you can say kinetic energy as function of x. And this is straight line, what you can see, total energy as a function of x. So keep in mind, J main not a single time, multiple time Bachaji. J main Bachaji not asked a single time. They asked this concept here more than one time. More than one time. So currently, I'm not paying more attention for mains. Currently, I'll go for advanced and basis illustration. Right. So after this, students, I'll not go in much detail, but there is one question here which I wanted to discuss because those questions also asked in what I can say like student. Those questions are asked in J advanced here 1987. Yes, beta. This is one question here which asked in JEE Advance 1987. Right, beta? This is the question here asked in JEE Advance 1987. 2 marks question is there. What question says here? A particle is oscillating and has a frequency of oscillation is F. A particle is oscillating, has a frequency of oscillation is F. Then you need to comment what is the frequency for kinetic energy and potential energy, right? So let's try to understand, my dear, how this is here. Okay. So again here, first student, I'll make one diagram or basic graph for SHM. This is minus A. This is plus A. Students at extreme position. You can say kinetic energy is what? Zero. Student at extreme position. What you can say, my dear? Kinetic energy is what? Zero. Right. Bacha ji, this one here already I discussed. I can say theory class of oscillation lecture number one. This is the mean position. So if you are going towards, let us suppose you are motion like this, your motion like this, right? Or you can take also here. Here velocity is what? Zero. So velocity is zero, which is what you can say kinetic energy here, this condition. So particle which I will go through this here. Particle finally arrived at what? Mean position. And again here, particle will goes like this. As I said, particle is performing SHM. Will go with this here. And finally with a particle goes like this. So we can just make some graph. This is for going for this path, and this is for coming for this path. Beta, you can see if particle once you release from here, bacha, so velocity increasing, velocity increasing. Student, if velocity increasing here, so you can say kinetic energy is what? Kinetic energy, what about? Increasing, right? Kinetic energy increasing, students, so what you can say? Potential energy decreasing. Potential energy decreasing. Beta, if you are at mean position, yes, velocity maximum. So at mean position, which I can write kinetic energy is also maximum. What, my dear? Kinetic energy is also maximum. Right. Now, student, once if you will, once if you will cross mean position. So what you can say? Kinetic energy started decreasing. Kinetic energy what started decreasing, and beta G, potential energy started increasing. Potential energy started increasing. Right, my dear? Okay, this is plus amplitude. Again, here from here only. This is plus A and this is minus A. Same thing, but just in reverse. If you have taken turn from here, so you can say that the potential energy decreases and kinetic energy increases. Here, bacha, again you can say potential energy increases and kinetic energy decreases. So here you can say beta at mean position, kinetic energy is maximum and beta the potential energy you can say minimum. At extreme position, potential energy maximum and kinetic energy minimum. Right? Okay. So this is the question here, which I said, asking J Advanced 1987. If frequency of oscillation of particle is F, then frequency of oscillation of kinetic energy and potential energy is 2F. So just beta this point you can note down here in your somewhere. Just beta take snapshot, my dear. Yes, student take snapshot. I wanted to turn the page here. Yes. So just beta note down in note. Yes, my dear, note down in note. Right. So this is if frequency of if frequency of oscillation of particle is f, then frequency of oscillation of kinetic energy and potential energy is 12. Beta, keep in mind here. This is question beta, as I say, ask a student that is J Advanced 1987, 2 marks question here. So if frequency of oscillation of particle is F in SHM, then student frequency of oscillation of kinetic energy and potential energy is 2F. So student keep in your mind at this point. Right. So now student, I'm going to solve a few questions here, which is asked in J Advance, right? Based on energy. So just now I finished concept of energy in SHM. So I'll try to do all question based on energy only. So keep in your mind. Now, beta, this is first question here. Means first question already solved. This is question number 2 on energy. This question is student asked in JEE advanced, my dear. That is 1994. 1994. Okay. Uh, now, beta, you can just go through this here. Right. Okay. Hmm. Yes, beta. 1994, yeah. What's the big deal? Beta, I'll write here little questions. An object of mass, do first here. An object of mass 0.2 kilogram executes simple harmonic motion. Students executes simple harmonic motion or oscillation along along the x-axis with with a frequency with a frequency of 25 upon pi hertz at the position x is equals to 0.04. X is equals to, my dear, 0.04 meter. X at the position x is equals to 0.04 meter. The object has kinetic object has kinetic energy of 0.5 joule and potential energy potential energy 0.4 joule. The amplitude of oscillation is in meter beta. We have to find here, right? So my dear, listen here carefully. Students in solution. Have a look here. Student, this question either beta mention x na. So students, you can use here this result also. Kinetic energy is a function of x, potential energy is a function of x, or I can tell in better way. What we have to find, student? Student, we have to find amplitude. So you can use here total mechanical energy conservation. What, my dear? Total energy. I hope all of you remember, student, kinetic energy plus potential energy. What, my dear? Kinetic energy plus student, you can say potential energy, right? Total energy is what, my dear? Kinetic energy plus beta Z, potential energy here. So this is the total energy. Which kinetic energy, how much mentioned? Yes. My dear, kinetic energy is mentioned 0.5 joule. Potential energy, student, 0.4 joule. So you can say bacha 0.5 plus 0.4. So total energy you can write zero point 0.9 joule. Right, my dear? Okay. Students, here total energy formula we know. Already I derived. So total energy you can write zero point 0.9 joule, right? Total energy bacha. That is, you can say half of Ka square, half of Ka square, which is equals to zero point 0.9 joule. Beta, just now I said here, K you can write K upon M is equals to omega square. So value of K you can write M into omega square. Yes, beta G. So here you just replace 1 by 2 K beta you can say M into omega square A square, which is nothing but is equals to zero point 0.9 joule, right? Students, omega you can use here. Omega is equals to 2 pi f. F is mentioned in this question here. How much? So beta, you can say omega is equals to 2 pi and f what beta? 25 by pi r. So you can say this is what cancel. This is what cancel. So omega you can write this is what 50 radian per second. What, my dear? Omega you can write 50 radian per second, right? Okay. Or beta directly you can feed the entire values here. So this is students. Mass beta, how much mentioned here? Yes, beta. Mass also mentioned here in this question here. 0.2 kilogram here. So you can say, student, this is 0.2 kilogram, right? And what about omega square? Omega square beta, I can write directly here. This is 50 whole square beta. This is what beta is? 50 whole square here, right? Okay. Then what's about it? You can say F beta. Hmm. BB square A square is equals to zero point 0.9 is equals to zero point 0.9. You can say beta. This decimal finish here. 2 and 2 finish bacha. So A square you can write 9 upon 50 whole square. 9 upon 50 whole square here. Finally you can solve bacha part. Yes. You will solve bacha amplitude you will get. This is 0.06 meter. This is what? 0.06 meter here. So this is the way which to do this question. J advanced 1994. J advanced which 1994. There are many questions here, but I can say I need to pay some attention. So just go through the questions first, right? Energy of a system. There are many questions. Yes, bacha. One more questions here, which I wanted to solve. That is, students, I can say, hmm, there are more than one correct answer here. 1989. Yes, beta. Just have a look at next question. Uh, this is students JEE beta. advanced 1989 student. They asked 2 mark questions. Right. So listen carefully, my dear. I'm very happy to share those I can say watching stream live of physics points. Right, my dear. Okay. So this is what student questions here. I'll write here question once. A linear harmonic, a linear harmonic oscillator, linear harmonic oscillator of force constant force constant 2 into 10 to the power 6 Newton per meter and amplitude 0.01 meter, right, has a total mechanical energy, has a total mechanical energy of 160 joule, right. Then yeah, there are many options, right. So beta, I can say option first, maximum potential energy is beta G. I'll write in short here. Potential energy maximum is 160 joule. 160 joule, no beta. 100 joule, beta. Maximum potential energy. Now, students, options number second, kinetic energy maximum. Kinetic energy maximum is 100 joule. Right. Option number C, beta G. Maximum potential energy. Maximum potential energy is beta 160 joule. Last option, student. Maximum potential energy. Maximum potential energy is 0. You can say that, yeah, you can say here, this question J8 was 1989 and 1994 almost similar, right? Because in this question, this one they mention here uh, kinetic energy and potential energy. But in this question, student, what they mentioned here, I can say total mechanical energy. So we have to find this following data. This following data, right? So listen, beta ji, carefully, everyone here. Okay. Come to the point here. The questions. Yes, beta. Uh, I hope all of you are, beta. I hope you have taken SSR. Now, beta, I'm going to solve the questions. Listen carefully, my dear. So I can say, student, this is solution of this question there. In step one, beta, you can write here. Total mechanical energy, or you can say total energy here. You can write in beta way. Total energy is mentioned, beta. How much? 160 joule. 160 joule, right? So, bacha, the maximum kinetic energy, yaar, if you remember, this is what half of Ka square is equals to 160 joule, right now, bacha? So, just we'll go through this here. K is mentioned in this question here, maybe. Yes, there is mentioned here, force constant. So, we'll get easily amplitude here. We can get easily amplitude from here, bacha. So, half of K. K beta how much? 2 into 10 to the power 6. 2 into 10 to the power 6 into beta the A square is equals to 160. These two finish here. You can say this is finish here. So you can say amplitude whole square is equals to 16 upon 10 to the power 5. 16 upon beta what you can see 10 to the power 5. Right. So bacha ji for this condition, you can write for the things here. This is bacha ji total mechanical energy here. So half of Ka square because we wish to find in this question maximum potential energy, maximum kinetic energy. So beta do one thing here. Just leave this one. Let us suppose I wanted to find maximum kinetic energy. Because you remember here, kinetic energy function. Kinetic energy as a function of x. You can write half of Ka square minus half of Kx square. If you want to find maximum here, so particle here, x goes to 0. So kinetic energy as a function of x, you can write half of Ka square. So bacha party, but here is questions here. How can we get value of A? A is mentioned in this question itself, amplitude here. Uh, because it will just go through this here, right? So bacha party, for this condition here, we have to find amplitude. So another mention here, amplitude. I forget here. Yes, student amplitude also mentioned here for the questions. That's not telling you write down all data first. I can say that the total mechanical energy is mentioned. Uh, K is mentioned, bacha. 2 into 10 to the power 6 amplitude also mentioned here. Just 0.01 meter. Yes, in meter here. But I'll use your entire values over here only. So kinetic energy as a function of x half into 2 into 10 to the power 6 into which 0.01 whole square here. 0.01 whole square which party. So what you can say which half of 2 into 10 to the power 6. 1, 2, 3, 4. Right. So beta I can say 4 here cancel each other. 2 to 100 joule here. So we will get your kinetic energy maximum, which is 100 joule. Any option is there? Go and check it. Yes, Bombay is correct answer here. Bombay, my dear, correct answer here. This is kinetic energy maximum. What, my dear? 100 joule. Kinetic energy maximum, dear, what you can say? This is 100 joule here, right? Okay, fine. But after this year, we have to find remaining things here. Okay, we can get easily our remaining data. How? Because this is in the question here. Total mechanical energy is mentioned, right? So Vitaji will go through here. I can say just make Vita one normal graph here. So Vitaji, what you can say total mechanical energy. Let us suppose that this is I'm considering. I hope all of you remember it. I repeat it multiple times. Mean position. This is what you can say left extreme position. This is the right extreme position. Right. These all things are very common. I hope all of you remember. So let's better talk about. I can see this part only here. Mean positions to it. Either you can take this one, this one. Both are repeat telecast. You know everyone. Let us suppose a particle is here, left extreme here. So you can say what? X is equals to A. X is equals to A, right? So, bacha ji, for this condition here, if X is equals to A, so what about kinetic energy here? Zero only. Because what's the kinetic energy? Half of Kx square, maximum. I'm talking about maximum only. So, bacha, this is what? Beta, we can see zero here. Or if given here, left extreme, right extreme, whatever, kinetic energy zero only. Okay. So Bachchaji, what about total energy over here? Here? As usual, it remains same only. This is 160 joule. This is what, my dear? You can say 160 joule. Okay. So what about potential energy? It remains same only, which is equals to 160 joule. Because you know, yeah, what is the total energy? Kinetic energy plus potential energy. So this is remain zero here. So you can see this is the kinetic energy, which is equals to 160, which is equals to potential energy maximum. Right. So you can see here, what is the maximum potential energy which so we can see is here. That is option C is also correct. Option C is also correct. Right, Bacha? Okay. Then Bacha, let us suppose you can take if you are at what? Mean position. So x0 here. If x0 Bacha body, what you can say, my dear? Kinetic energy which is equals to 100 joule. Right. So beta, what about potential energy here? Or you can see total mechanical energy. This is 160 joule. So what about potential energy? If you are at mean position, this is what 60 joule. This is what 60 joule. So what is the correct answer, my dear, for these questions here? What is the correct answer, Bacha? You can say options number Bombay and what? You can say Canada. These two are correct options. The advanced 1989. The advanced Bacha party, you can say this is 1989 here. Okay, so these are the basic questions here. Literally, you must keep in your mind. Literally, which you have to must keep in your mind here because these are the questions. There is a very high probability they can ask, they can repeat the data as well. Right. So this is the bit of questions here which already asked. They asked you the one more question that is 199, but that is questions not much effective here. Yes, I'm not willing to discuss that question, right? Okay. So energy weighted that much. Now here I'll do few questions from my side because in energy they didn't ask too much questions in advance. Yes, they asked many questions. I can say student for means here. Basically, because energy is not much I can say applicable thing, but I can say for energy bacha for this condition here, literally they ask many questions. Okay, I'll see tomorrow. I'll see tomorrow, student. For time being, I'm going to do a few questions which is based on I can say energy, right? Okay, because my dear, just now here I finished the concept. Now it so I have to do here a few questions based on this. Okay, so this is first questions, my dear, goes to everyone. This is the first question, student, goes to everyone here. Right. So I can say, Vichaji, you have to find, you have to find which that is u as a function of x. What, my dear? U as a function of x here. Okay. Do this question once. It's Vichaji. Do this question once here. Okay. Or do one thing here. It's around 12:30. But I wanted to do a few questions based on energy. So these are the concept of energy, student. So you have to just keep in your mind energy concept here, literally very, very helpful to your few questions. Yes, bacha. So what question says, yes, beta, u as a function of x here. Students, you can take, let us suppose there is some expression, yes, little I remember. U as a function of x, u as a function of x. So this is, you can take beta alpha plus twice beta x square. Alpha plus what, my dear? Twice beta x square, right? Where alpha, beta, and constants. You need to find students time period of oscillation. Find time period of oscillation. Time period of oscillation, right? So just we'll go through this questionnaire. I'm not interested. Okay, I'll write once option. So this is students 2 pi root of 2 beta upon m This is 2 pi root of m upon 2 beta. Students, pi upon m of beta. Students, you can say last options here, beta upon m, right? So just we'll go through here these questions, everyone. So how to do this question here? That is the first question for everyone, right? Beta Ji, if you remember here, this little concept of work power energy. So in step one, beta, you have to write here first what mentioned in the questions. U as a function of x, this is alpha plus twice beta x square. Beta, if you remember little here, I can say for work or energy. So if you have a U as a function of x, so how can we get force and point? So differentiate beta one time here. F is equals to du by dx. What, my dear? F is equals to du by dx. This is 0 plus you can see 2 to the 4, 2 to the 4 beta x. F you can write with the 2 to the 4 beta x. Right? This is the force expression here. So if you remember everyone here we have to put minus sign. F is equals to what? Minus du by dx. Now, Bacha, so finally you will get, my dear, F is equals to minus 4 beta x. Now, beta, if you remember oscillatory equation of SHM, it's nothing here. You can say F is equals to minus kx. Both are look like very much similar. Very much similar here. So we can see, student, K is nothing but K is equals to 4 beta. K is equals to 4 beta here. Baby is to find time period. So in step one, finish, my dear. I'll do here step two here only, student. So this is step two here. So step two beta, what you can say? T is equals to 2 pi here. M upon K formula here, right? So this is, student, T is equals to 2 pi m beta and K is 4 beta here, right? What's the option? Any option matching with this? Okay, C. Okay, you can say bacha party for this question here. This is 4 beta. You can take negative out here. Why you are, yes, you can think like that now. Then to finish here. So you can say pi upon root of m upon beta. Okay, perfect here. Beta, any option here? Just go through this. T is equals to pi root of m by beta. Yes, yeah, daily, forever green. You can say, bacha, this is what? Daily or forever green. Right. Okay. Beta, after that, bacha, we'll do your questions on energy only, right? Yes, bacha, energy question we can do here only. Next question, बच्चा जी, I can take care. Uh, yes, बच्चा जी. What's the question here? A particle. Yes, beta. So what's the question here? A particle of mass. A particle of mass 2 kilogram moves in simple harmonic motion. Simple harmonic motion and and its its potential energy and its, my dear, potential energy U varies with position, x as shown. The period the period of oscillation of the particle period of oscillation of the particle is right. Means simply we wish to find time period. Right. So here student, I'll first draw graph, my dear. U as a function of x, U as a function of x. This is the graph. Mention the questions here. Okay. This point beta amplitude also mentions which is equals to zero point 0.4 beta. This is the constant point. This is, you can take one potential energy in beta joule and x beta g in meter. Babies to what point? Beta go through once here questions. A particle of mass 2 kilogram moves in a simple harmonic motion and its potential energy U varies with position x as shown. The period of oscillation of the particle is okay. We have to find a time period. We have to find, my dear, time period. Okay, I'll write options, student. So this is options first, my dear. This is 2 pi by 5 seconds. Bombay beta. This is 2 root 2 pi by 5 seconds. Canada beta. Canada beta. This is root 2 pi upon 5 in seconds are everywhere. Last students 4 pi by 5 in seconds. Right. Okay. We'll go through your option these questions here. How can we solve further, everyone? Right. Bachaji, this is the interesting point here. It's a what? If you remember your graph, so if the student, if he will remember graph, where gone here? Okay, I'll use another one. If you remember my dear graph here, just now I finished. You can see, my dear. This is what here. This line is mentioned one. So this is nothing here. It's a total energy. And this is what beta? Potential energy as a function of x. So beta, this is the same thing, student. Just you can compare from here only. So you can get here. In solution, you can write. In solution, students, you can write, my dear. That is, total energy is 1 joule. They mention here 1 joule. And they also mention here it's a dotted line. I hope all of you remember it. It's a total energy. So total energy is mentioned here 1 joule. Right. So here, student, total energy, I hope all of you remember. Half of Ka square, which is equals to 1 joule. Students for their year, I can ask what is the value of K and what about amplitude mentioned here? This is zero point 0.4, so no need to worry. Delegate your K from here. Half into K, bachcha ji zero point 0.4 whole square here, 1 only. So K beta you can say here 2 upon what? 0.16 beta 2 decimal here. So K beta what you can see 200 by 16 here. So 200 by 16 beta 4 times na? You can say here this is 50 by 4 12.5. K beta will get here. This is 12.5 Newton per meter. Newton per meter here. Okay, we'll get case. Then what's the big deal here to find? I can say time period. Now, bacha, we can easily do here. Yes, beta, we can easily do here. So this is what students time period here. So you can say this is 2 pi under root m by k. So this is 2 pi beta. Answer your mass. Just I wanted to see in terms of what a particle mass is mentioned here 2 kilogram. So you can say beta 2 kilogram. It's a gram here. So you can write 12.5 only. 12.5 Newton per meter, which right? So which you can say for this condition, if we'll see till 12.5 which okay. So this is 12.5. So beta just replace one. So this is 20 here. So T is equals to 2 pi 20 by 125. 5 times cancel here. 5 times cancel with so 5 for the 20 here and 5 25 here. So you can say T is equals to 25, which means what? 4 upon which? 5 near. 4 upon 5. This is beta what you can see 4 upon 5 here. Okay. Uh, this is beta 25 here. Just be careful beta. So we can take a square root which, right? So this is 2 pi which, and this is you can say 2 by 5. So finally you will get my dear. This is 4 pi by 5 seconds. Very good. Time period here you will get, my dear, 4 pi by what is student? Time period you will get 4. Just take snapshot, my dear. Take snapshot as student. Right. Actually, I can see previously it was not visible. Now it's visible as student. Take snapshot once. Yes, I'm very happy to share those candidates till those are uh, student. God bless you. May I know, student, where are you watching and what's your name? I'm very happy to see students. I'm putting also effort here and also interested to see class this time. Very happy to see Richa. Okay, have a look, Richa. Next questions, my dear. Have a look, student. Next questions here. So, student, here and now I'm just paying more attention here. Problem based on energy only, right? Okay, fine. So, Richa, have a look here. Everyone, next. Next, everyone will go through here. Okay, beta. Next question. So this is students. Yes, beta. The potential energy of a particle, the potential energy of a particle, the potential energy student of a particle of of mass 2 kilogram in SHM is 9x square beta. Student, 9x square in joule. Here x is displacement, right beta, from in position. If total mechanical energy, student, if total if total mechanical energy if total mechanical energy of the of the particle is 36 joule. Then, then maximum speed. Then student, maximum speed of the maximum speed of the particle is student maximum speed of the particle is right. So student, I'm writing options. Just taking consideration. This is what my dear 4 meter per second. Bombay student, it's 2 meter per second student. Next option number C, 6 meter per second. Last my dear 10 meter per second. Right. Okay, fine. So have a look, Vicha. Just have a look at further solution of this question. The potential, I'll read once questions, my dear. The potential energy, student, the potential energy of a particle of mass 2 kilogram in SHM is 9x square joule, x from mean position. If total mechanical energy of the particle is 36 joule, then maximum speed of the particle is. So we wish to find what is the maximum speed here. So particle is at mean position, right? So you can say what is the velocity maximum, which is equals to a omega, which is equals to what, my dear? You can say this is equals to basically a omega here, right? But in the question mentioned here, mechanical energy, that is what, 36 joule here. So I hope all of you remember here, the particle is at mean position. Yes, have a look, student solution of these questions here. If particle, if particle is at mean position, so you can easily say here, you have basic idea. That is what, my dear? X is equals to 0. X is equals to 0 at mean position here. Potential energy minimum. You can see bacha potential energy is 0 here. Therefore, total mechanical energy is equals to maximum kinetic energy. Now, beta, you can say total mechanical energy because you know here, total mechanical energy is nothing but it's a kinetic energy plus potential energy. Potential energy is 0 at mean position. So you can write total energy is equals to kinetic energy. And kinetic energy is what? You can say half mvs square. And kinetic energy maximum mention. That is what? 36 there. So you can write this is 36, which is equals to half. And what about mass here? This is 2 into beta g. You can say, my dear, this is Vx square, V square here. You can say this is Copas. So V will get 6 meter per second. Any option is there, my dear? Any option is there? Yes, here, Canada. Yes, beta ji, Canada is correct answer. Student, Canada is correct answer here. So I can say paper will not get tough at all. Here I'm trying just do more numerical so that you can easily understand the things. More numerical, more in fact also I'll slow here because it's a live stream classes. You are not in front of me, so I'm considering at least each and every student who those who are paying attention, trying to listen the class. Definitely, anyone can learn the concept of physics. It's not tough at all. Physics not tough at all. Right. So students, one more question here. I'll take bacha, then I'll stop live session here. Right. I'll again connect you tomorrow. Right. Okay. Just do your basic questions based on this. Okay. One more question, bacha. I'll do that is J main 2015. Yes, beta. Uh, this is what, my dear? JEE student JEE. It's main 2015. Okay. So, student, there is a graph is mentioned here. Uh, we have to select which one is the correct graph. Right. For a simple pendulum, A graph is plotted between kinetic energy, potential energy against displacement, right? Which of the following graph represent correctly? So we can select here. So its following is correct representation. Shows following is correct representation representation of graph, kinetic energy, potential energy versus x. Here you can write simply, right? You can say which. So this is first option beta, first, second, third, and last. Okay. So students, kinetic energy, potential energy here only. This is the displacement student x. Beta kinetic energy. This is x. Kinetic energy, potential energy. This is kinetic energy, potential energy, kinetic energy, potential energy. Finally, students, I can write kinetic energy, potential energy as a function of x. So here first I'll draw this is beta pot graph of dimension kinetic energy, and this is the graph beta dimension for potential energy. Right. Next बच्चा जी I can say option Bombay. This is u as a function of x, my dear, and this is you can say beta. It's a kinetic energy as a function of x. Beta in option C. This is a potential energy function of x, and this is kinetic energy as a function of x. Right. And last beta, that is potential energy as a function of x, and बच्चा जी kinetic energy as a function of x. Now tell me which option is correct? Which option is correct? No doubt here. You can say Bombay is correct forever. Bombay is correct forever. Student, I'll do here more questions on energy tomorrow, students. Now here I'm going to stop live session. All the very best. I'm very happy to see everyone. Those I can say night till 1 o'clock. Watching stream live of you can say physics one.